Hi there, I'm How, and this is just another video of me solving random numerical problem. So we have longest increasing subsequent. So we're given an array num. We need to return the longest strictly increasing subsequent. So in this example, it's gonna be this one, right? 237,101, right? The 5 is gonna be ignored, right? In this case, it's gonna be the whole array, right? 1, 0, 1, 2, 3, right? And then in this case, every member are all the same. So just one. So we can use dynamic programming to solve this problem. We have our DP, right? And the DP, right, gonna equal to the DP gonna represent the longest increasing subsequent up to the I index, right? And it's not gonna be default at one, right? Because each number can be its own subsequent, right? So let's say we are starting from the second number, right? Because the first number, right, it's just gonna be one. Because the longest subsequent up to index 0, it's just the maximum is just one number, right? So we start from the second number. Okay. So yeah, we just iterate from the beginning, right? To find a number that is larger. So if it is larger, sorry, if it is smaller, right? If the current number is larger than the previous number, right? Which means we have an increasing subsequent. If it is larger, in this case, 10 is larger than 9. So we ignore, right? We don't do anything. And we're gonna jump to the next number. So 10 is larger than 2, right? So we ignore. 9 is larger than 2, so we ignore. So next number, right? 10 is larger than 5. 9 is larger than 5. 2. 2 is smaller than 5, right? So we update the level subsequent, right? At the DP at index 3 here, right? It's gonna be equal to the max, right? Of DPI, which is what we currently having, right? So this is I, right? And this is J, right? And between the DP at J plus 1, right? Whichever is larger, right? So we need to be conservative here, right? We need to take the max of either like what we are currently having or what we will have, right? Or what we will potentially have if we use this number inside the increasing subsequent, right? So that is what the plus 1 is for. And then if we found a number that is smaller than I than the current number at I, right, which means we're gonna have an extra number in the sequence. So in this case, the DP at I is 1. The DP at J is also 1, right? But 1 plus 1 is 2. Is larger. So we update here is become 2. So we try the next number here. I. So 10 is 10 is larger. We ignore. 9 is larger. We ignore. 2 is smaller, right? So we just take the maximum. So this become 2, of course, right? 5 is larger, so we ignore. And we go to the next one. 7, right? 10 and 9 are larger. 2 is smaller, right? So this become 1 plus 1 is 2, larger than 1. Right? 5 is also smaller, right? So we take the max of what we have, which is 2, right? And what we have at J, which is 2 plus 1, right? 3. So 3 is larger. Let's update it to 3. Yeah. So now you can see that that is why we are taking the maximum, right? 3 is also smaller, right? Because 2 plus 1 is equal to 3, right? So what we already have, so we ignore. Okay, so now we go to 101, right? Every number is smaller than 101, right? So we're gonna start from here, right? We got 2, right? Also got 2 here, right? 2 here. Now we have 3, new maximum, upgrade to 3, right? Also 3 here. Now we have 4, right? So 3 plus 1 is 4. It's larger than what we have, so upgrade to this to 4, right? Move on to the next number, 18. All the number except 101 is smaller than 18. So this also become 4, right? Right. When we get to 7, this will become 4. And yeah, well, we are done. So at the end, right, we just have to iterate to the DP and return the maximum subsequent. Right. Why not the last one, right? Because it might be a 1, right? Because the number are not even like sorted. We're gonna have something like this. If the last number is 1, so the array is not sorted, we don't have anything warranty. So so the DP will be representing the longest subsequent uh longest increasing subsequent up to a certain index, right? So we just have to iterate to the DP and find the maximum, the longest subsequent up to a certain index and return that. So that is gonna give us of n square, right? Because we are doing a nested loop here. Okay, so let's code this up. So DG equal to array.from. The default line is num.9, and then the default value is going to be 1. Okay, and we iterate from the second number, remember, because the first number, the longest subsequent, right, up to index 0 is just 1, right? Maximum is 1. Less than num.length, plus plus, and j is equal to 0, j less than I, j plus plus. Right. So if num.j is less than num.I, right, which means we found a new number, we update the dp equal to the maximum of dpi, and then dp set plus 1. Okay, at the end, we can just return the maximum. So dp the reduce, the max, and the num, the method max, up max, and the num. Okay, so it worked. So the follow-up is that can we come up with an algorithm that is running n log n time complexity, right? So let's think about that. So when it is log n, I think about binary search, right? So we can only use a binary search approach here. So let's explore this alternative. Right. So instead of the DP, we don't need the DP actually, right? We have a subsequent array, right? Subsequent array. And we can start out by putting the first number inside it. And we can start at the second number. So whenever we found a new number here, right? We will binary search the subsequent array, right? To trying to find the correct position that we can insert, right? So in this case, it is left and right starting at the same position, right? In the middle, right? If we find the same number, right? Then we will just be we will just so if we found so for example, if it is 9, right? Right? We will just return this index, right? So this number can be replaced because we only allow strictly increasing subsequent, right? Duplicate are not allowed, right? So um so yeah, but it is 10, so we just have to find the index, right, to insert it. So the middle, right, is larger, so right equal to middle minus one. So right about overlap, so we return the left, right, which is index 0 here. So we set 9 here, right? Okay, we'll go to the next number, just 2, right? Left and right, same position, right? So the insert position gonna be 2 here, right? Gonna be 0 here, right? Now it's 5. Okay, so if the number is larger than the last number in um the subsequent, right? We just added, right? In this case, it is larger, right? So 9 is larger than 10, right? So that's why we need to find a position to insert. Whatever it is larger, it is an increasing subsequent, so we don't care. We just insert it. Okay, and we can see 3 here. So we have to find a correct position to insert, right? So the middle is here, right? 2 is smaller than 3. So left is equal to mid plus 1. Right? The mid is here, right? 5 is larger than 3. So right is equal to mid minus 1. Now they overlap, so we return the left, which is the next one here. Right, so we rewrite the 5 with 3, and then continue. Right. Okay, so 7 is larger than the last number in the subsequent, which is 3. So we found a new subsequent, right? A new number in the sequence we added. Right, same for the 101. Right. Okay, now we find 1. Because 1 is smaller than the last number in the subsequent. Let's say this is 18. Okay, 18 is smaller than the last number in the subsequent, right? Smaller than the last number in the subsequent. So we need to find a correct position to insert it, right? So left and right. Mid is here. 3 is smaller, right? So left from here, right? Mid is here. 7 is smaller, right? So left equal to mid plus 1. Mid is here. 18 is this one is larger, right? So we set right equal to mid minus 1. So we return left, which is the next 3 here. So we rewrite 101 with 8. Okay, and we are done. So at the end, we can just return the line as a subsequent, right? So every time we need to do the binary search, so that is log n, right? We need to do it how many times? N time, right? So n log n. Okay. So let's code this up. All right. So we need our sequence equal to the first element in the nums array. The sequence. I need to return the sequence line at the end. Right. Okay, we iterate to every single number starting from the first. So if the number, right, is larger than the last number in the sequence, right? Then we can just push it into the sequence. Pretty simple, right? Otherwise, right, we need to find the correct index to insert the new number into sequence, right? So you can do const index equal to, you can binary search it. You can binary search to find the index, right? Passing in the target, and we can set the sequence at index, right, equal to nums of I. We have a target here. Okay, so we just have our left and right as usual. Right equal to something, to the number line minus 1. Oh, actually sequence, right? We are doing by research on the sequence. So y left is less than or equal to right. We need to calculate the mid equal to left plus math of uh, right minus left divided by 2. Right. So if the sequence right at mid is equal to the target, we can just return the mid index length. Yeah. So we don't want duplicates. So if we find the same number, we just return the mid index. Otherwise, right, we just if it's larger, we go to the left by setting the right index. Otherwise, we go to the right by setting the left index. And at the end, we can just return the left index here, like this. Okay. And as you can see, the runtime is like 99%, so which is like much better than the previous solution, right? So thank you for watching.